The infinite universe. Imagine a night with no end. A silent, endless expanse filled with ancient lights, each a dying echo from stars that ceased to exist long ago. Every point of light in the sky represents a galaxy, each containing billions of stars, planets, and perhaps stories of life. We humans are but a flicker, an instant, in the grand timeline of the cosmos. And yet, since the first time we gazed upon the stars, one haunting question has lingered. How will it all end? The universe had a beginning, born from fire and chaos. But like all things that begin, it too must end. The only mystery that remains is how and when. The beginning of everything. To understand the end, we must return to the beginning. Around 13.8 billion years ago, the entire universe, space, time, and energy, exploded into existence from a point smaller than an atom. In the first fractions of a second, unimaginable energy condensed into matter. Particles formed atoms, atoms built stars, and stars gave birth to galaxies. It was the dawn of time, the birth of everything we know. But from that very first moment of expansion, the seeds of the universe's death were already planted, because everything that expands eventually changes. The expanding cosmos and dark energy. In the 20th century, astronomer Edwin Hubble made a shocking discovery. Galaxies are not static. They're moving away from us, and the farther they are, the faster they flee. The universe isn't just expanding, it's accelerating. What's driving this mysterious acceleration? Scientists call it dark energy, a force that makes up nearly 70% of the entire cosmos. We don't know what it is. We only know what it does. It stretches the very fabric of space, pushing galaxies apart, turning the night sky ever darker. If dark energy continues its relentless push, then one day, even atoms themselves may be torn apart. The death of stars. Stars are the heartbeat of the universe, furnaces that forge elements, illuminate galaxies, and make life possible. But even stars die. In a few billion years, our sun will run out of fuel. It will expand into a red giant, swallowing Mercury, Venus, and possibly Earth itself. Then, it will collapse into a faint white dwarf, cold, dim, and lifeless. As eons pass, other stars across the cosmos will meet the same fate. The brilliant night sky will fade, one by one, as the universe slips slowly into darkness. The cosmic lights go out. Forever. The Big Freeze, the cold death of the universe. The most widely accepted scenario among scientists is called the Big Freeze. In this future, the universe continues expanding forever. Over trillions of years, galaxies drift apart until even their light can no longer reach one another. The cosmic temperature falls close to absolute zero. No heat, no light, no motion. Black holes will eventually evaporate through Hawking radiation, releasing faint whispers of energy into an empty void. And in the end, the universe will become a dark, cold ocean of lonely particles. No stars, no life, no change, only silence. The Big Crunch. The universe collapses. But some theories suggest a different fate, the Big Crunch. In this scenario, gravity eventually overpowers dark energy, The expansion slows, stops, and reverses. Galaxies begin to collide and merge. The temperature of the cosmos rises again, and the universe collapses inward upon itself. Everything, stars, planets, space, and time, falls back into a single, infinitely dense point. A mirror image of the Big Bang. And perhaps, from that singularity, a new universe is born. The Big Rip, the most terrifying end. But if dark energy grows stronger with time, there is a far more violent ending. The Big Rip. In this apocalyptic future, expansion accelerates beyond control. First, galaxies are torn apart. Then solar systems unravel. Planets are ripped from their orbits. Finally, even atoms themselves are shredded, as the very fabric of space-time disintegrates. Nothing survives, not even the laws of physics. The universe doesn't freeze or collapse. It tears itself apart. Eternal darkness. After the stars fade, after the galaxies vanish, and after time itself loses meaning, what remains? Darkness. A black, empty expanse where nothing stirs. No light, no warmth, no memory. Space itself stretches endlessly, yet there is nowhere left to go. The universe becomes a graveyard, a silent monument to what once was. And in that vast nothingness, even eternity feels meaningless. The rebirth hypothesis. But some physicists believe the end might not truly be the end. Energy cannot be destroyed, it only transforms. Within the quantum vacuum, fluctuations might ignite new bursts of creation. A tiny spark could trigger another Big Bang, giving rise to a new universe. Perhaps this has happened countless times already. Our universe could be just one bubble in an endless cosmic ocean, a multiverse where every death gives birth to new beginnings. Reflection, our fleeting moment. The end of the universe lies trillions of years in the future. But for us, fragile beings on a small blue planet, our time is unimaginably brief. Knowing that everything will one day vanish isn't a reason for despair. It's a reason to appreciate now, to love, to learn, to wonder. We exist in a rare and precious moment. An era when stars still shine, when galaxies still dance, and when life still dares to dream. We are the universe's way of knowing itself, tiny sparks of awareness flickering in the cosmic dark. And perhaps, when all else fades, that awareness is what truly lasts.